Hey, welcome back. Good morning. Hope everyone's doing well with the homeschooling and remote learning. So let's go over yesterday's exit ticket, and it kind of a couple step problem when you look at it. At first, it seems really easy. You might be looking, going, okay, to practice for an Ironman competition, John swam 86 hundredths of a kilometer each day for 3 weeks. How many meters did he swim in those 3 weeks? Well, then you have to kind of think about some things. Well, for one day, it's 86 hundredths of a kilometer. Well, think about that in terms of a week. So for 7 days, it's going to be 6 200 kilometers. Well, I know 7 days is 1 week. So he's doing this for 3 weeks. So we've got to do it for 21 days. So we're going to take that 86 hundredths of a kilometer, multiply it by 21 because that's how many days are in 3 weeks. And what we're going to get is 18 600 kilometers, which would be the same as saying 6 200 times 3, 18 600. Now I've just got to simply turn this into meters. So I'm going to take 18 600 kilometers equals itself times, in parentheses, 1 kilometer. Now all I've got to do again is say, okay, that equals 18 600 times, and now I'm going to convert. I'm going to, in parentheses, I'm going to write what the conversion is for 1 kilometer, which is 1,000 meters. So it's going to be 18 600 times 1,000. And now all I've got to do is move that decimal to the right 3 times, 1, 2, 3, and that's going to leave me with 18,060 meters. Hope you guys were able to get that. So hit me up for a question using any of our devices. If you still have a question about this today, I'd be happy to explain it in more detail. All right, let's go on to our calendar. All right, so we're still dealing with area using improper fractions and mixed numbers. All right, so the first thing we've got to do is we've got to find our length and our width. And I'm going to slide this over like I have been each day. All right, so now let's figure out the length. Now remember, the length is our bottom number. Our width is our side number from here to here. Our length goes from here to here. Okay, so we know that area equals length times width. So first of all, let's identify our length. So I know from this point over here where 1 is, from here to here, is 8/8. Now all I've got to do is bring this down into individual eighths: 9/8, 10/8, 11/8, 12/8, 13/8, 14/8, which is the same as 7/4 up here. So I can do it either way. So I'm going to have area equals, and I can say 14/8 or 7/4. Okay, let's stick with just the 7/4. Apologize, I didn't look up and see they lined up. And now let's look and see where our width is. Okay, so as we go down, here is 1/4, 2/4, 3/4. Well, 3/4 is 6/8 right to here. So we go one more eighth, and that would be 7/8. So now I'm going to, since I've got it, I've got 7/4 times 7/8. Now, really simple. Area equals length times width. I'm going to multiply numerator times numerator, denominator times denominator. That's going to give me 49/32. Okay, now if I do this as fractions, as division, this means 49 right here divided by 32. So here's 49, dividing it by 32. We have one group of 32 and 49 if I use partial quotient. So 1 times 32 is 32. I'm going to subtract. 9 minus 2 is 7. 4 minus 3 is 1. There's nothing left to bring down. And so I have 1 and 17/32. Now, I had a complaint this week. So remember, pause as we go. Someone said, you never do area, Mr. Dagnan. Her name rhymed with Shmena. But anyways, you can do the math in that. So we're going to take this and we're going to just find our length again. Okay, so we're going to find our perimeter of this shape. So we have 7/4 here. So remember, we know that opposite sides are equal. So this is going to be 7/4 here. Now on a rectangle, the other set of opposite sides are equal. So we knew that this was 7/8. So this is 7/8. Now this would be a great time to pause. Now let's do this algebraically. So we're going to say 7/4 times 2 plus, and we're just going to do this as some expression, 7/8 times 2. And the reason we're doing it times 2 is we have two groups of 7/8 right here. We have two groups of 7/4 right here. So 7 times 2 is 14/4 plus 7 times 2, we have 14/8. Now I've just got to have a common denominator before I can add them. So I'm going to take 14/4. It equals itself with a long line. And what do I have to multiply this 4 right here by so it will equal 8/2? What I do to the bottom, I do to the top. Okay, so that's going to leave me with 28/8 plus 14/8. And if we do 28 plus 14, we're going to get 42/8. And now all we've got to do is do fractions as division. 42 divided by 8. 8 goes into 42 5 times. 5 times 8 is 40. We have 2 left over. So we have 5 2/8, or as Raina is probably screaming out loud right now, 5 1/4. Now there was an easier way to do this. How many of you caught that? So when we had 14/4 up here plus 14/8, so we did have at one point, so we had 14/4 and then we had plus 14/8. Now, one simple thing would have been just to simplify 14/8 and turn that into 7/4. And then we could have added 14/4 plus 7/4. We would have gotten 21/4. Well, that would be 21 divided by 4. Going to be the same exact answer. 4 goes into 21 5 times. 4 times 5 is 20. We have 1 left over, and now we have 5 1/4. Exactly as we got on the other answer. Okay, great time to pause right now if you want, so you can keep up. I'm going to hit erase right here. Now, let's take a look at this, and let's look at this as a fraction and a decimal. So I'm going to start out with just adding these as fractions because I see a pretty simple way of doing it. So take like 30 seconds, and I want you to figure out what both sides are going to be as a fraction. Now, this could be written as a mixed number. You could also write it as an improper fraction. Won't matter, okay? So let's look at this side right here. And they're both equal. I think we can all agree on that. How this one right here is equal to this one right here. And this is 1 whole. This is 1 whole. And down here, it's a half. This is a half. Okay, so that can be written as 1 1/2. Okay, and over here as 1 1/2. So if we add both of those, or we could write it as 3/2 plus 3/2. Now, if I do it that way, this is going to be really fast. 3/2 plus 3/2 is going to be 6/2. Go to fractions as division. 6 divided by 2 equals 3. Or do it over here, 1.5 plus 1.5. Half plus a half is a whole. Put down the 0, carry the 1. So we have 3 and 0 halves, which is the same as 3. Now, if you did this as a decimal, okay, we could have written this as 1. Sorry about that. Could have written it as 1.5 plus 1.5. Line up those decimals in both numbers. Okay, line up the tenths column with the tenths and the ones with the ones in both numbers. 5 tenths plus 5 tenths, 10 tenths. Put down the 0, carry the 1. And remember, we trade 10 tenths for 1 whole, because this column over here becomes 10 times greater, or it is 10 times greater than this column over here. 1 plus 1 plus 1 is 3. So, should have it right there. Now, you also could have written 1.5 as 1.50. Remember, they are the same. 1.5, 1.50, 1.5000. It doesn't even matter. You could go on forever. So let's go on to our lesson. Okay, pause as you need to. All right, so we are continuing to convert. Now we finally get to use our lesson from our book. So we're going to start with just a 3 read. Okay, you have worked with measurement units in earlier grades. Now you will convert between different units in the same measurement system. Use what you know to try to solve the problem below. Okay, Lyra finds an antique dresser that is 4 feet wide. She wants to know if it will fit in her room. She measures the space in inches. How many inches is the dresser? Okay. So what are we going to do here first of all? How many of you noticed this portion, 1 foot, is 12 inches? This would be a perfect chance to put a table in here. Let's do reading 2. Find important information. Lyra finds an antique dresser that is 4 feet wide. She wants to know if it will fit in her room. She measures the space in inches. How many inches wide is the dresser? Okay, so let's just start with that. Let's start with our table. Okay, we are going to go feet. We're going to go inches. All good mathematicians from time to time are going to use a table. So we could start out really simply with 1 foot, 12 inches, 2 feet, 24 inches, 3 feet, 36 inches, 4 feet, 48 inches. Now, instantly that's going to give us our answer, but let's take a look. So let's do it exactly as we have been doing it all week. So we know that the dresser equals 48 inches slash 4 feet looking here. But let's see if it's right mathematically. Okay, so we're going to take 4 feet equals 4 times, in parentheses, 1 foot. Now this is where we get to make our trades. All right, slide this up a little bit. So that's the same as saying 4 times. Now I'm going to make my conversion. 1 foot equals 12 inches. Okay, so now that equals 4 times 12. Go right over here. 4 times 12. 2 times 4 is 8. 4 times 1 is 4. So we know we have 48 inches. All right. So pause as you need to. All you're going to do is do this lesson with me. Okay. Now we're going to do a look back. Look back at the problem on the previous page. Is the number of inches in 4 feet greater or less than the number of feet. Okay, so read it again. I'm sorry, I need to pull this down. So look back at the problem on the previous page. Is the number of inches in 4 feet greater than or less than the number of feet? Take a quick pause. Squiggly right here. Explain. All right. So the number of inches in 4 feet, is it greater than or less than the number of feet? What did we come up with?